A sudden flash lights up the lunar night, brighter than the sun, for just a moment. No air, no sound, just a blinding bloom of light racing across gray dust. The most powerful weapon humans ever built, unleashed on a silent world. But what would actually happen if a nuclear bomb exploded on the moon? At T0, the bomb's core compresses, uranium or plutonium atoms splitting in a chain reaction. A fraction of a second later, energy equal to tens of kilotons of TNT bursts outward. On Earth, that energy forms a fireball and a mushroom cloud. On the moon, there's no atmosphere. So no blast wave, no sound, no rolling firestorm. Instead, a sharp flash floods space with light and radiation. The energy still spreads, but in a vacuum, it expands as pure heat and X-rays, not air pressure. The surrounding lunar dust vaporizes instantly, creating a glowing plume of plasma. Without air resistance, it rises straight up in a perfect arc, scattering microscopic glass beads across the surface. On Earth, nuclear explosions are terrifying, partly because of air. Air carries shockwaves, turns fires into storms, and spreads radioactive fallout through wind and rain. But the moon has none of that. So the classic mushroom cloud, a column of hot gas rising and folding over, can't form. There's no weather, no winds, no burning cities. The explosion's energy still exists, but it behaves differently. About 85% of the bomb's energy turns into light and heat, and 15% into penetrating radiation. With no atmosphere to absorb it, much of that energy escapes directly into space. The moon's vacuum acts like an open door, letting the blast expand freely, quickly fading to nothing. At ground zero, the temperature spikes above 10 million degrees Celsius, hotter than the sun's core. Lunar rock and regolith within several meters instantly vaporize. Farther out, the ground melts into glass, forming a crater maybe 50 to 100 meters wide for a Hiroshima-scale device. A thin halo of vaporized material expands outward at several kilometers per second. In a few seconds, it freezes into tiny glass spheres and falls back like gray rain. These impact beads are similar to the ones found at asteroid impact sites on Earth. Since there's no air to scatter debris, everything that isn't launched fast enough just falls straight down. No fallout drifts across continents. It all stays local. Radiation from the explosion, mainly gamma rays and neutrons, bursts outward at light speed. In space, there's nothing to absorb or slow it down. Anyone nearby, say an astronaut within tens of kilometers, would receive a lethal dose instantly. But beyond that, radiation intensity drops fast with distance. For people on Earth, 384,000 kilometers away, it's negligible. The radiation dissipates long before reaching us. Even satellites would be mostly unaffected, except those directly in the line of sight at close range. However, the flash of X-rays and gamma rays would temporarily ionize space around the moon, possibly affecting lunar orbiters and communications for a few minutes. Yes, briefly, if the bomb detonated on the moon's near side, the flash would be visible even with the naked eye. It would appear as a sudden, intense glint, maybe lasting 1 or 2 seconds, followed by a faint glow. No mushroom cloud, no dust storm. Just a silent, ghostly flash in the darkness. High-speed telescopes would detect it easily. In fact, the US Air Force once studied this very idea. In the late 1950s, during the Cold War, they proposed Project A119, a plan to detonate a small nuclear bomb on the moon to show American power. It was canceled, partly because scientists realized it would offer little scientific value and risk damaging early satellites. Not significantly, the moon has been hit by far larger explosions, asteroid impacts releasing energy equivalent to millions of megatons. A single human-made nuke, even the most powerful ever tested, the 50-megaton Tsar Bomba, would only create a crater a few kilometers wide. It wouldn't change the moon's orbit or trajectory. The explosion's energy is tiny compared to the moon's total mass, roughly 7.3 times 10 to the power of 22 kilograms. To alter that orbit meaningfully, you'd need energy billions of times greater. In short, you can scar the moon's face, but you can't move it. No, because the moon has no air or weather to lift radioactive dust into space. The debris would stay near the surface. Some fine particles might escape the moon's weak gravity, but they'd disperse in the vacuum, not travel in a stream toward Earth. Even if trace atoms reached our atmosphere months or years later, they'd be too few to detect. Earth's magnetic field would likely deflect most charged particles anyway. In terms of risk to life here, it's effectively zero. The danger would be to instruments, rovers, and lunar bases nearby. A nuclear explosion could damage any active spacecraft or experiments on or near the surface. It would contaminate the local site with long-lived isotopes, cesium-137, strontium-90, and plutonium residues. That area would remain radioactive for decades. For future lunar explorers, it would be an off-limits zone. However, because there's no weather to spread contamination, it would remain confined to the immediate crater. So, while such an event wouldn't destroy the moon, it would permanently scar a piece of human history. In the cold vacuum of space, a nuclear bomb loses much of its horror. There's no air to burn, no people to harm, no echo of destruction. But the act itself, detonating such power on another world, would mark a dark milestone. It would mean humanity carried its most devastating invention beyond its home planet. The real question isn't what would happen, it's why would we do it? Our technology can reach the moon. Our restraint should too.